Going, it's Russ here, and whenever the Web3 and crypto ecosystem takes a turn for the worse, it's important to refocus on the people who are actually building things in the background that could have huge implications on where we go in the future. These are new tools, applications, and ideas that we have the unique opportunity to dive into now before they get more popular and more widely known as they get adopted. And the best place to find these projects are at the ground floor, where new builders are teaming up and experimenting together to come up with these new ideas, and that often happens at hackathons. And today we're going to take a look at the 10 finalists from a recent hackathon held at ETH NYC, an event put on by ETH Global. We're going to look at Web3 music social media platforms, NFT gaming infrastructure, and UI and security improvements that we're all going to end up using, and much more. So let's dive into it. But before we do, subscribe to the channel if you're into this content. I'm going to be bringing more stuff like this all the time. And the first project we're going to take a look at is Steam Tokenizer. This is a bridge between Web 2 digital assets and Web 3 digital assets. Now let me explain. You might be familiar with Steam, the most popular PC gaming marketplace where you can actually purchase video games. But what you might not know is that Steam actually has a marketplace where you can buy and sell in-game assets, and you can actually not just buy them from the company that makes them, but actually trade them and purchase them and sell them between other players. Right now we're looking at my inventory of skins that will make the weapons in the game CSGO look different. And what's cool about this is that each of these different weapons has a price that they're currently going for on the market. This one is $3.11 Canadian right now. And when you think about it, this is kind of like the way NFTs work, right? These digital assets that you're able to trade back and forth, and there can be an actual independent market price for these different digital assets. The only difference is that Valve, the owner of Steam, they are the ones who actually control this Steam marketplace. They control the servers, and as a result, they could censor or stop any transaction from going through. That's why the blockchain is a lot better for NFTs, right? Instead of just having one central server that a big company controls, it's a distributed system that will stay the same and is immutable for all time. So Steam Tokenizer kind of plays with these similarities between Web 2 marketplaces and Web 3 marketplaces, and has created a bridge so you can actually take your in-game Steam items and represent them as NFTs on the Ethereum blockchain. So Steam Tokenizer has a bot that acts as a user on the Steam marketplace, so that you as a user on that marketplace can send your in-game digital assets, like one of those CSGO skins, to this bot. Now at that point, the bot allows you to mint a Web 3, like an Ethereum native copy of this digital asset that will live on the Ethereum blockchain. Now, the cool thing is the original asset that you send to the bot gets held in escrow by that bot, and it doesn't get returned to you until you burn the NFT that's created. As a result, you could mint one of those CSGO skins that we just looked at, trade it on the blockchain, someone else can buy it, and then they'd be able to burn that NFT in order to reclaim from escrow that in-game item on the Steam marketplace. Pretty cool, right? The bot even takes the image associated with the in-game item and uses that as the art for the NFT so that you can see which item is which. And you can actually see this here in this OpenSea inventory. Of course, this is just on testnet right now, but you can see these M4A4 gun skins, exactly like I was showing you before from CSGO, actually living on OpenSea as an NFT. Now, in the past, Valve, the company that owns Steam, well, they've said they're not very into the whole NFT idea. So likely if this project were to go further, they might actually poke the bear a little bit there. But at the very least, it would start a dialogue about like, hey, look at these new innovations that are happening. Hey, maybe we can sort of incorporate some of this technology into the way that we do things here at Steam. Next up, we have Burn My Wallet, a solution that allows you, in the event that your wallet gets hacked or compromised, to signal to everybody else that, hey, this is not me anymore, this could be anybody. Now, the name is a little bit misleading. This doesn't actually burn your wallet or destroy it. That's actually not something that's possible. But what it does do is it puts a little hacked marker in your wallet. Now, this marker is a soul-bound NFT, an NFT that can't be transferred or traded. Now, using this soul-bound NFT, other applications are able to look into your wallet and say, if that Burn My Wallet NFT, the soul-bound marker there, is in that wallet, well, it's very likely that that wallet has been hacked. Unlike in Web 2, when an account is hacked and the hacker can change your password and boot you out of the account, that can't happen in Web 3 as long as you still have your private keys. You can access your wallet or your account. So obviously, if your wallet was compromised, your first order of business would be to get as many assets off of that wallet as possible and get them into a safe, uncompromised wallet. But your second order of business would likely be minting a Burn My Wallet soulbound NFT. Now, the beauty of this is that Burn My Wallet has created APIs and different plugins that other applications can use to search your wallet to find out if there is a soulbound NFT token in there. If I were to click this button and mint my Burn NFT, instantly every application that builds in this functionality would be able to see that that wallet is hacked and display that to other users to prevent them from getting scammed by that wallet. I think the best use case here is to prevent phishing scams. In a world where decentralized social media might become more and more prominent, not only do hackers have access to all the assets in your wallet, but they also have access to your social profiles, giving them the sort of leeway to scam the people that have been following you. Hopefully with technologies like Burn My Wallet, scams like this will be far less effective in the future. But now moving on to our next project, we have Tsukiji. Tsukiji is built on top of OpenSea's new Seaport protocol. I absolutely love that OpenSea has sort of put this out there because it allows other applications like this to plug into those contracts and sort of get a head start when they're building their new applications. Now this application works kind of like a bartering system for NFTs. You can put up a certain number of NFTs and assets that you want to trade for another set of NFTs and assets, and you can sort of say, hey, this is what I want to get for these assets that I'm putting up. Here you can see it's these 3 Azukis, and this person wants 20 ETH for that, as well as 1 Bored Ape. When you're creating your listing, you can add a number of assets that are inside of your wallet, and you can add a number of assets that may not be inside of your wallet. You can search for the contract address, the NFTs that you want to receive from the trade, and you can also list the duration and the tip, which is a cool feature. This tip feature is an amount of ether that will go to the person who fulfills your order, trying to sort of make this more lucrative for the person who actually puts together the assets that you're asking for. Any potential imbalances between the asks and the offers, as well as this tip price, might be a good opportunity for people who want to arbitrage or see like, hey, there's a difference in value between these two sides when I include the tip. So maybe I'm going to go out and buy these assets, put the order together for the person who's asking for it, and then I'll be able to sell their assets along with the tip and make more money than I spent buying the assets that the person was looking for. Pretty cool. Next up is a project called Safenode, which markets itself as the rug pull preventer for NFT launches. Now, typically when a new NFT project is launched, there might be a roadmap or things that the team that put together the project says they're going to do, but really after the mint happens, there's nothing that's actually obligating them to do any of the things they said they were going to do, often leading to team members walking away from the project with all that ETH in their pocket. Their idea is to put the roadmap on chain, forcing the team to actually do the things they say they're going to do before receiving the entirety of the ETH that they've raised from the NFT sale. I love mechanisms like these that make the actual funds raised from an NFT sale more community owned and more distributed by the people who actually own those NFTs. We see projects like this where you can mint NFTs and then at any point you could just sell that NFT back for at least a portion of what you originally paid for it at any point. Those funds are sort of locked away, as well as new mechanisms like what Nouns has been doing for almost a year right now, where every single sale doesn't go to the individual creators, it goes into a treasury that the NFT owners are actually able to manage in the way that they want to. Next up is a project called Perl, a messaging platform that allows people to message large groups of people based on their wallet address and what that individual wallet address is holding. The idea is that project leaders can make new notifications and tag them with different sort of categories: mint, allow list, events, utility announcements, jobs, news coverage, security, general, and send this out to anybody who's holding a specific NFT or digital asset. They've done this by building a custom messaging protocol that searches for these wallet addresses and sort of connects them with the message sender. And you can see here they've actually made a mobile app that will send those notifications to each individual wallet address holder. Next up is a project called ETH DOS, and no, that's not DOS for denial of service attack. That stands for degrees of separation. You might have heard of something called the Bacon number, which is a game that you can play. You can pick any actor or actress and see how many degrees of separation they are from actually working with Kevin Bacon. Most people aren't more than 2 or 3 degrees away. And ETH DOS has taken this concept and turned it into a sort of social experiment game on chain where you can give NFTs to your friends, your actual one-to-one friends, and they are able to sort of of prove that they are friends with you through ZK snark technology and issue new NFTs to their friends. Now, using this ZK technology, anyone who has one of those other NFTs is able to trace themselves back to you and show how many degrees of separation they are away from you. And the cool thing here is that you don't actually have to sort of know the path on how you got there and like who knows who individually. Using the ZK technology, you can just prove that you are this many degrees of separation away without revealing the information about how you actually got there. Next up, we have to take a look at Reverb, which is an artist and listener music platform that's built on top of the Lens protocol, which is a social media Web3 protocol where every single post and every single person you follow is represented as an NFT. So again, you build that social graph there. You can take it between different apps. Very, very cool. And it's all done on the Polygon blockchain, so extremely low gas fees. On this platform, you can follow and collect songs from the various artists that you're interested in. As you listen to this music NFT that you've collected and increase its view count, simultaneously as you're listening to it, you are given some of the creator's creator tokens, and this is streamed to you directly with Superfluid, which is a great technology that actually allows continuous streams of ERC20 tokens to be sent to any individual wallet address. Now, of course, there are questions like if you bought this NFT and just left it on loop, would you just like be farming that individual creator's token? And would that actually be a positive benefit for that creator? Well, that remains to be seen, but I think that the main thing is that there's experimentation going on here to give more tools to allow artists to connect with their fans and to reward their most loyal supporters. And the fact that this is all built on the Lens protocol means that the relationships and the sort of social graph that's built out by every single artist on the platform can then be taken and moved to other social media platforms that are also built on top of the Lens protocol. Unlike traditional Web 2 platforms where you have to stay where you build your audience, like if you have 1 million TikTok followers, you can't leave TikTok because all your followers are there. For applications like Reverb that are built on the Lens protocol, you can actually take that graph of followers with you. They're going to be following you on every single different app, not just the one that you build the following on. And this is better for users, right? Because each individual application has to compete and be better and better than the competition because there's no artificial lock-ins. You don't have to stay in that ecosystem if someone else offers something better. So damn cool. Next up is some Web3 gaming infrastructure called Gittle. This is something that actually allows you to share accounts and assets between multiple players within the same game. This allows individual users to join a guild, and once they've joined that guild, they can set their own rules for what assets they want to allow other members from the guild to use on their behalf. It allows you to pool assets together with a larger group of people that might help to get you farther in the game. Now, I've played a lot of World of Warcraft in my life, and they have this thing called raids where 10 to 25 people team up to take on a particularly challenging boss. But as with anything, to get 10 to 25 people all together at the same time, it can be kind of challenging. But imagine this. Maybe your best player isn't able to make it to the event or the raid. Instead, you would be able to use some of that member's gear, or maybe even have another player be able to play that player's account, even though they weren't there, because they're able to share it through this Gittle protocol. I won't get too into the weeds, but I think the architecture here for how this all actually works is pretty freaking cool. It allows every individual account or user to be represented by a Gnosis multisig, where that user, as well as the contract that manages the guild, is also a user in their multisig. This allows any assets that are inside of that multisig to be sort of used and loaned out by the protocol, and it also speaks to the composability of Web3, that they can use just normal Gnosis multisigs and sort of build their own protocol on top of that, putting their own smart contract in as a signer on that multisig. Wow, blown away. Next up, we have some killer data aggregation and visualization software. Right now, when you deploy a smart contract that's your sort of decentralized application, it's pretty hard to get user data, like which users have used this how many times. You can go to Etherscan and you can count each one individually manually, or write sort of complicated scripts to get this information. But with this, which is called Meshlink, you're actually able to get this information far more easily without a technical background. Any user can point this software at a particular smart contract, and then the software software, Meshlink, will be able to sort of go out there and aggregate and scrub all of that data, pull it all in, actually convert it to JSON files, which makes it easier and cheaper to actually access the data, and then it can display it all here for you. Now, this is extremely powerful. You can see all of the wallet addresses that have been able to interact with that smart contract, what their ENS names are, how many transactions they've done on that smart contract, when their last transaction was, when their first transaction was, all of this valuable data. And once you've done this for one smart contract, you can also do it for another one and compare the two data sets, saying, hey, maybe users of this type will also use this app. Let's see if that's true or not. Using this data analytics, well, we can actually get far greater insights than what we can typically when we're just sort of looking at Etherscan. And last but not least is a project called Safenode, which is just so cool. Anyone who's signed a MetaMask transaction knows that sometimes when you sign that transaction, you don't have any assurances of what it's actually going to do. There's some hard to read data on that MetaMask. You can click sign and kind of just cross your fingers that it's going to do what you expect it to do. This is an RPC and block explorer that you can actually point your MetaMask to, and it adds an extra step that you need to go through before that transaction is actually officially submitted. And this is where the value of Safenode is. It will actually do a simulation of that transaction and give you insights on what happened. You can see all of the actions that happened as a result of you signing, again, this is a simulation, that transaction before you actually truly submit the transaction. And they also have worked in here some great other infrastructure called user reports. Now, this allows each and every user who interacts with a smart contract to, following that transaction, report whether or not they think it was safe or not. And it sort of gives this other credibility rating for different functions that can be called on smart contracts that gives the user a little bit more assurance that, hey, this is likely something that's pretty safe because it doesn't have that many negative reviews. I absolutely love to see experimentation in this space because as someone that works full time in the Web3 industry, even when I'm signing transactions, sometimes I'm nervous about the contract and sometimes I don't know exactly what's happening because the data just isn't very readable, and Safenode makes that a lot better. We're going to need to make leaps and bounds from where we are right now before I feel comfortable getting my mom to sign a transaction. But with all of that said, nothing makes me more bullish about the ecosystem than taking a look at the ground floor. What's happening? What are the builders doing? What are the potential implications of this down the road? It really makes your mindset a lot longer when it comes to this whole Web3 ecosystem, because this is not a 1-year play, a 2-year play, a 3-year play. Being in this ecosystem now is a decades play, and this makes me all the more confident to stay here for the long term. Thank you so much for watching, everybody. Subscribe to this channel if you haven't already done so. I'm bringing more and more content all related to Web3 on this channel, so subscribe for more and let your friends know. There's not a lot of Web3 content out there, so I'd appreciate the sub and the share. But with all that said, thanks so much for watching, everybody. I hope this video helped you out at least a little bit, and I'll see you next time.